Okay, now one of the topics that we are supposed to cover in this course is personal finance. It's a quantitative literacy course. I'm not going to give you a bunch of formulas for finance. You get those anywhere if you understand functions and understand really have a really good understanding of a pre-calculus course, even better, an understanding of a calculus course. You don't need those formulas. You can figure it out. And that's the way I'm approaching this. I'm giving you the basic mathematics behind it all. Not a bunch of shortcuts, not a bunch of tables, not a bunch of stuff. You know, what's the mathematical content here in terms of basic functions? Okay, so finance and exponential functions. We have an investment. P stands for principal, T stands for time. And we're going to do this over a period of years. Now, y'all have a hard time thinking in terms of 20 years. You know, I think in terms of millennium myself. But, okay, but 20 years. Let's say we've got a 20-year period. And you have an investment that's going to grow 10% every year. Okay? That means that investment, for reasons that we'll be able to analyze in a little while, but not today, is going to double every 7.2 years. Okay? So that we can start with a principal. How much money do you want to start with? Okay, well, let's just start with an easy number to understand. You can start with anything, $1 million or whatever. There are too many zeros. I'm going to write $1,000. Say we start with $1,000, and what does it happen? What happens to it in 20 years? Well, in a little over 7 years, it's going to double. So let me just do a little subdividing here. Here's 10. Here's 5. Here's 15. Okay, so in 7.2 years, so here's 6, 7, 8, 9. So that'd be right about here. Okay, about here. This value is going to double. So, of course, if it doubles, that's going to put it here. Should have put it a little lower, because if I double it again, it's all the way up here, but we'll live with that. And to get a third doubling, well, it's going to be up in my writing here. So you need to plan, and I didn't plan quite well enough there. But anyhow, 7.2 years here, and we're going to have doubled money, $2,000. So we can come over here, and we can come up here. And here's a point on our graph. Then in another 7.2 years, it's going to double again. Well, it's going to be about 14.6 years, just shy of 15. So I could make tick marks and relabel, but let's just say it's about here. It's going to be about here. So it's going to be up here. So you see that the amount is going up like so, consistent with an exponential function. Now you could take your basic exponential function and I'll just draw it to the right of the x-axis. So we have values 4, 2, 1. That's not good at all. Let's fix that. 2's got to be a little lower, and 1's got to be a little lower. That might be better. Okay. And we're going to go out, well, we're just going to do the basic exponential function. So we've got 1 here, and 2 here, and I probably don't have good intervals there. I can't see from this angle. And no matter how I try to compensate, I can't. Can't do a real good job of it. Anyhow, I've got this point, then this point, and this point. So here we are with the basic exponential function. I can relabel this. Okay? I can relabel 2 to 14.4. I can relabel 1 to 7.2. And I can just say, okay, since I used 1,000 here, these numbers could be in thousands. So I have 1,000, 2,000, 4,000. Now I'm not all the way out to 20 years. You figure out how we might get there. We could go to the complete basic exponential function, knowing that if x equals 3, 2 to the x is 8, so we could put 8 up here, and we'd have the number 21.6 out here. With that labeling, well, I could figure out where my units are. This is 7, so subdivide this into 7, which is not that easy to do. Then subdivide this into 7 more, and here's 14, and all that stuff. You could do the scaling. But now the graph represents how much money you have at different times. So if you want to know how much money you're going to have in 10 years, you say, okay, 10's about here. And if you have a good graph, and this is just a quickly hand-sketched graph, now you'll be able to check this out. But this looks like, let's say if this is 2, that'd be 3, so this would be about 2,400 question mark. Okay, so if you have $1,000 now, and if you have a 10% annual interest, you double in 7.2 years. And of course, 10% annual interest is not easy to come by right now, and it wouldn't be very secure, would it? Got to think about those things too. In any case, you see that in 10 years, you would have maybe $2,400. It's a ballpark estimate, but this is a picture of how investments grow. Now, if you have variable, if your rate of growth varies and so forth, and that rate of growth is different than rate of change, we'll make that distinction, but not today. Things get weird, but you can handle it mathematically, especially if you know a little calculus. Okay, well, anyhow, just the idea of how we could relabel the basic exponential graph to a very basic financial phenomenon.